Last time we stopped at step 5. Let's just do a quick review. In step 5 we have DAB, which makes glyceraldehyde 3-phosphate using the triose phosphate isomerase, okay, because those two are isomers of each other. Moving on to phase 2. Phase 2 is from steps 6 to 10, okay? So now in phase 2, we have the glyceraldehyde 3-phosphate, okay? And basically it's going to oxidize. This is known as an oxidization reaction to 1,3. Wait, let me get my laser pointer. Okay. So this is going to oxidize, known as the oxidization reaction to 1,3 biphosphoglyscerate. Glycerate is because we're losing the aldehyde right here, the aldehyde group that we had here, and we're switching it to a carboxyl group, so that gives us glycerate. And in order to do oxidization, we also need reduction, so we're basically reducing the 2NAD plus to NADH, okay? And that's basically, we're multiplying everything by 2 in this reaction. So what we have, because we have the glyceraldehyde 3-phosphate, we have 2 molecules of them. Remember from step 4, we said that we have from step 4 and 5. That means we have in total 2 molecules. That means we will have 2 inorganic phosphate, 2 NADH, and 2 NADH plus 2 ions of hydrogen, okay? That's where we see all the 2's in the reaction. Now again, this reaction is reversible. So basically this is a recall. That oxidization is basically we are removing a hydrogen, adding an oxygen. Reduction is the addition of a hydrogen, removal of oxygen, okay? Now, right here, we have the hydrogen ions, which came up in the reaction right here. We have 2 of them, and then for this reaction to proceed, and we're switching from an aldehyde to a carboxylic acid, we need an enzyme called glyceraldehyde 3-phosphate, and another one called dehydrogenase, meaning we are removing a hydrogen for oxidation to reduce NAD plus to NADH, okay? Next, step 7, this reaction is reversible, and we're basically taking what we've already made in the step 6 process, which is 1,3 biphosphate glycerate, okay, plus ADB, which will give us 3-phosphoglycerolate and ATB. So ADB will always result in ATB. Now we have a magnesium ions as cofactor, and then since this is biphosphate right here, and this is phosphate, so we lost a phosphate group, and that phosphate group is lost because it was transformed from ADB to ATB. It was transferred into ATB. It gave us a yield of 2 ATB. That's when we start to see some money coming back from our investment. And the enzyme that we've used is phosphoglycerolate kinase, okay? Now, moving on, we have, this is like basically this process right here, the transformation of ADB to ATB. The process is known as substrate level phosphorylation, okay? Formation of ATB by a phospho group transfer. Moving on to step 8 of this reaction. Step 8 of this reaction is basically reversible. Just memorize that steps 1, 3, and 10, those are irreversible, and the rest of the steps are all reversible, meaning they go both way. So now we have the 3-phosphoglycerolate right here being transformed into 2-phosphoglycerolate. So basically, those two are isomers of each other. And in this case, since they are isomers, we use an enzyme called mutase. Okay? Instead of isomerase, mutase is also for isomers. And basically, we're removing the phosphor group from the 3 to the 2. Okay? So basically, we use the full enzyme is called phosphoglycerolate mutase, meaning move functional group from one position to another position, from the 3 position to the 2 position. Step 9, we have it as reversible. For step 9, we're taking the 2-phosphoglycerolate from the previous step and we're turning it into phosphoenol pyruvate plus the 2 water molecules. Okay, this reaction is known as a dehydration reaction, where we're basically removing water molecules from the reaction, making it as a subproduct. The enzyme that is used is enolase, okay, because we have enol right here, enolase. And this enolase enzyme, when we go through this reaction, it has an intermediate known as enolic intermediate, just to let you know. But then it's very fast, so it goes directly, skipping the intermediate. Now for step 10, this reaction is irreversible, okay? And we're basically taking the phosphoenol pyruvate, okay? And we're switching it into pyruvate. Since we lost the phosphor right here, what happened is we are making ATP, okay? So we have 2 ADP molecules, which will give us 2 ATP molecules. Then we have our ions as cofactors, magnesium and potassium. And then we have, as an enzyme for this reaction to proceed, we need this enzyme, which is called pyruvate kinase. Kinase stands for the loss of phosphate group, okay? Finally, this is the whole glycolysis reaction. I hope it made sense. And just remember that in steps 1 and 3, we are losing 2 ATP molecules. This is in phase 1. It's known as the investment phase. And then in steps 7 and 10, we are generating 4 ATP molecules. So in each step, we're generating 2 ATP molecules from ADP. That means we are losing a phosphate group, okay? And it's the payoff phase, okay? So we have 4 ATP. And then moving to the net reaction, just to see where we got all of that. In the net reaction, we have the glucose in step, remember in step 6, right? So in step 6 right here, we've gained 2 of all of those. That's where we see them in the original net reaction right here, 2 NAD, and then 2 inorganic phosphate. We have the 2 NADH, and then we have the 2 ions right here, the 2 ATPs. We should have, and then the 2 hydrogen waters. That's it. That's the whole reaction. I hope that made sense. And just remember, by the end of this, that in reactions 1, 3, 10, they are irreversible, okay? They prefer products. Okay, but in the rest of the reactions, they are reversible and they prefer reactants. Okay, that's the whole glycolysis process. I hope that made sense, and thank you so much for watching and sticking by. I'm gonna be posting about biochemistry because I have an exam coming up, and that's about it. Thank you. Have a good day.